Okay, this time around we have another algebraic expression that we have to try and find the limit of, and we're going to begin using substitution as we did in the previous example. So let's write out the question. And its limit as x approaches negative 3 of x squared plus x minus 6 over x plus 3. Use your substitution, and that's going to be negative 3 squared plus negative 3 minus 6. And on the bottom we're going to have negative 3 plus 3. Well, if we do that, negative 3 squared is 9, plus negative 3 is 6, minus 6 is 0, and negative 3 plus 3 is 0 on the bottom as well. Now 0 over 0 is indeterminate, which means we just don't know what that limit is. We cannot say. 0 over a different number would just be 0, and any other number, let's say 5 divided by 0, that would be allowed, and we would simply say that the limit doesn't exist. But in this case, if we have 0 over 0, or later on we'll see infinity over infinity, in either of those cases, 0 over 0, infinity over infinity, the limit is indeterminate. We don't know what it is. We're not allowed to leave a problem in that state, so we have to continue working if we can find another method that will give us an actual limit. So we sort of go back to the start of the problem and take a different approach. And the simplest approach very often is just to factor the two expressions. So on the top, x squared plus x minus 6 can be factored. So this is going to be the same as the limit as x approaches negative 3 of, okay, let's factor the trinomial on top. And remember, it can be any type of an expression. This is a trinomial, but it could be difference of two squares, or some other similar expression. Factors of x squared are going to be x and x. And you have to excuse me, having a little bit of trouble with the pen here. Factors of 6 that have a difference of 1 are 3 and 2. There's going to be a plus in front of the bigger number, and they're both going to be different. So a minus here. So it's going to be x plus 3 times x minus 2 on top, and x plus 3 on the bottom. Now, you can see here that you have a similar factor, the same factor on the top and bottom, x plus 3. Cancel those out, and that leaves you with the limit as x approaches negative 3 of x minus 2. Now at that stage, once you've done your cancelling, try substitution again. So that's going to become minus 3 minus 2, which is minus 5. So that's our limit. So the process here is to show, first of all, as we've done in this first step, that the limit is indeterminate, and then try factoring. If you can get a common factor to cancel out after you do your cancelling, do your substitution then again, and whatever answer you get should be the limit. So using this method, an algebraic approach, we get negative 5. Again, look at the graph. This is the graph of the function, and we want to get closer and closer to negative 3 from both sides. Okay, so as we move closer and closer to negative 3 on our x-axis, find out what the graph is doing. And the graph is moving closer and closer to negative 5. Now the thing is that the graph has a hole there. It doesn't exist. Okay? So there's a hole there, but the limit is still negative 5, because the height that the graph is approaching from the left and the right is going to be negative 5. So there is a hole, but the limit as x approaches negative 3 of this function f of x, just call it f of x rather than writing out the whole function again, is going to be negative 5. Okay, so again, the graphical approach and the algebraic approach both have to agree. Okay, so you'll get some more practice with these now. Again, remember, Show that it's indeterminate by direct substitution. Factor the top and the bottom if possible. Cancel out any common factors and try substitution again. Later on in the course we'll look at a different method for doing these, something called L'Hopital's rule, but that can't be done until after we've learned how to differentiate. So this is the preliminary method and is often the method you're going to use in the long run anyhow. Okay, thank you and good luck with the next examples.